let's tackle this question. It's it's an electrical question. So we're looking for transfer function. We're basically going to change this function t to s. So what you're going to look for here, it's basically we're going to look for v or s divided by vi s. This is what you should be looking for. So we're going to start with this one, but you can see here the resistor and the capacitor are in parallel. So first things first, let's find this one. R1 is in parallel with C, the capacitor C1. So in transfer function, R1 is going to be equal to R1, while C is going to be equal to 1 over SC or CS. However you'll write it. This one is multiplication. The order doesn't matter that much. So to find the total product here, it's going to be the product over sum. We're going to start with the product on top, so it will be R1 times 1 over SC divided by, that is the product over the sum, divided by the sum is R1 plus 1 over SC. This one you already know the answer. It will be R1 over SC. While for this one you need to calculate it, is equals to, let's find the LCM. This one is R1 basically over 1, so it's going to be SC, which is the LCM. So 1 into SC it's just SC. So R1 times this, it's R1 SC plus SC into SC, 1 times 1, 1. So this one is the bottom one. So we're going to have R1 over SC, the top one, divided by this one. So it's just like times SC over R1 SC plus 1. This and this will cancel. So our final answer is going to be R1 divided by R1 SC plus 1. This one is for the parallel part. So to find the transfer function here, let's use the voltage divider rule here for our case. So for the voltage divider rule, it basically says that okay, you can just go check on that, but to be quick let me just go through it. So for the voltage divider rule, we're going to see that VO is equals to, you can denote with T, but there is no need because you introduced S already. So VOS is equals to R2 is equals to V1, sorry, is equals to V1, the V1 outside is equals to V1 into R2, the one that is the output, which is R2 on top, and then the R2 is going to be divided by the whole of this one, which is R1 over R1 SC plus 1, this one, and then plus this one, R2 over total. In short, you're going to have whatever you want to look for, the output divided by the total. So the total is this one and this, but the output is this one. So let me go to the other side. I don't know. Let me go to the other side of the right one part. Let me just use this one side. So after finding this, we're going to calculate the bottom one. Remember, this R2 is over 1, so we can just write it R1 over R1 SC plus 1 plus R2 divided by 1 is equals to, let's find this one first. This one is going to be, the LCM is this one, R1 SC plus 1 times 1, of course, so it's just 1. So this one into this 1 times that, it's R1 plus this into this, R1 is C plus 1, this times this, it's R2 into R1 is C plus 1. So the final answer there is R1 plus R2 into R1 is C plus 1 divided by R1 is C plus 1. And remember, this one was to be divided by, R2 was to be divided by this one, so it's like R2 divide by the whole of these, so we're going to take the reciprocal, of course. Then you're going to have R2, which is at the top, times, of course it's R2 over 1 times R1 SC plus 1. Let's just put this one in brackets, and then you divide it by R1 plus R2 into R1 SC plus 1, like that. And remember, we had a VI here, this one, so it's now going to be VO S is equals to VI into R2 R1, let's just multiply it, R1 R2 SC plus R2 divide it, hope it's seen, divide it by this on the bottom one, which is R1 plus R2, this one times this one, let's just do it direct, R2 plus R1 R2 SC, yeah, like that. So to find VO over VIS, we're going to divide both sides by VI, or we multiply by 1 over VIS times 1 over VIS. This one will of course cancel this one, then this one will be VO S over VI S is equals to this one. Now let's try to write it in order. R1 R2 S is normally written from this side most of the time, but me I just like writing them together. Then C plus R2 divided by R1 plus R2 plus SR1 R2C. That's the transfer function of this RC network circuit. Thank you.